know how many questions we are going to have at the end, so I just want to get through this as quickly as possible. So you have an 8 by 10 piece of paper. Boom. There's my 8 by 10 piece of paper. Then it says you're going to chop off 3-inch squares out of each corner. So what you're going to do is you're going to cut this away, which is a 3 by 3 corner. Cut that away down here. Cut that away down here. And cut that away down here. It is a little bit, yeah. So what we want at the end is we actually want kind of a rectangular prism type shape. A rectangular prism type shape, which might look something like, I don't know if we can make it exactly with the paper. But when I fold up the corners, I'm going to have something that looks like this. Right, because I fold up those corners. Well, that's just a rectangular prism. That is length times width times base, or just find the base and multiply it by the height. Well, I'm cutting out 3-inch sections. I'm cutting out 3-inch sections. So if this is an 8 by 10 piece of paper, if this was normally 10 inches, and I cut 3 inches away down here and 3 inches away down here, this length right here is 4. I'll pick another color. Let's get purple. Which means one of our widths down here is 4. Well, the other one is 8. So 8 minus 3 and 3, I'm going to have only 2 left over. So that means this is 2. And my height has to be 3 inches. Because when I fold this up, I'm folding up something that's 3 inches high. So the volume of this is just 4 times 2 times 3. Or 8 times 3. Let's go ahead and put that down. So our volume, as for the volume, right? Yeah. So our volume is just going to be 4 times 2 times 3. In other words, base times our height, which is going to be 24. Did I use centimeters? I used inches, so we'd probably say inches cubed. Why did I pick this problem? I'm not saying necessarily it would be on the test. This is a very famous math type question. You'll see it when you get to like calculus and stuff where we're maximizing areas. It is a very common problem, kind of like that pool problem, that pool garden that we had, where you were putting a pathway around a pool and it turned into a garden halfway through. Those types of problems are very prevalent in ACT, SAT type questions. Same thing as this one. It's very easy to just come up with something you just cut corners out, and it might not be a square, it might be like a 2 by 4 inch thing. So you really have to think through what's happening. All right, but any questions on how to do that? Okay, in that case, I'm going to open the floor to just questions on homework right off the bat because I wasn't here. How did it go with the video and the sub? And
it was cool.
Did you like doing that? I don't know, for future. Was it nice being able to watch it at home and then come into and just work?
Mm-hmm. I like that
Grace
so
didn't
much
like
that
it.
I'm like here.
Oh, what'd you do it for?
No, like because when I was gone before.
Oh, yeah. All right, Robin.
Number 11 on the first homework.
So 12.1, number 11?
Yeah.
The painting
The long
thing?
one, yeah.
The long one. So it was just an exercise in patience, basically. I mean, it was.
That's fine.
It was. You had to realize how many different shapes you had. Maybe I'll take a better picture so we can see everything all in one. Okay, so we were supposed to come up with how much to paint it, so you had to come up with, so they gave us this front half, and I'll kind of put in red what's happening. So I was looking at this triangle. Well, that triangle's on both sides. That's why I put you have 2 triangles. And it's 2 times half the base times the height. The base of this is 12, and the height turned out to be 2.5 once you did all the subtracting away from this, which equaled 30. Then we had, I just went right down the side. I said we have 2 traps, which is going to be 2 times half the height times base 1 plus base 2. Oh, yeah.
It's funny, like when I checked the answer key, it was was like upside down.
Yeah, Sabrina put that, and I read it. I put it in correctly then, right after. Yeah,
Oh.
yeah. Just say something if you. I forgot who said they. Someone said they just turned over their computer or
That's
something.
what I-
Oh, okay. Yeah, no. If something's upside down, just let me know, and I'll fix it if possible. But anyway, so that's 2 of these trapezoids. Maybe we'll do that in purple, because we have a front and back, right? And then I think I just picked, which one did I do? 24 by 30. So I picked these 2 to be these 2. And then we had 2 long rectangles that were 40 by 24. So these were our total square feet and how many gallons we needed. The shingles were just this section and this section. So we had 2 of each of those sections. Do you kind of see where you maybe made a mistake, or?
I didn't really make a mistake. I was just like really confused.
Oh, does it make sense now? Okay. Yep.
You didn't make a mistake, but you were confused.
Look, I started it.
I didn't do enough work to make a mistake. No.
Exactly.
Yeah.
Can you go for number 10 on this one?
Oh, are we okay on this one, I guess?
Yeah.
Okay. Number 10 was that it was basically a cube with a hole bored out of it. So let's talk about what areas I'm trying to find. Well, the areas of the actual cube aren't so bad, because I just need to find the top and the bottom, right? And that was 4 by 8. Do you see what I mean? Maybe I'll color it in as I'm talking about it. So I'm talking about find that area, multiply it by 2. Where did I have that? I had that right here. All right. Then I would find like the side areas, like this little sliver here, which would be 2 of those, 2 10 by 4s. That's right here. So that is the top, bottom, left, right. Now we have to find the area of the face. Well, the face is that entire rectangle, subtract out the circle. Okay? So the face, let me color that in purple. I'm talking about it's all of this, which is just going to be the rectangle minus the circle. So that is right here. Because the face is 8 by 10. Let me subtract away the circle, which is pi r squared, or pi times 2 squared. All right, that is the face in the back. Now, if we notice there is an inside, it's not empty. So we have a cone right here. We have a cone right here. And whenever you have a cone, it's just the circumference of the circle times like the height or whatever. So that's where we got the 4 was the length of that cone. You see what I'm talking about? The cylinder, I'm sorry, the cylinder. And then we have 2 pi 2. Akshay.
Okay, how are we supposed to know that was a cylinder?
Because you can see it.
Because I thought it was just like a rectangular prism with a hole in it.
It is. No. I understand what you mean. Like you might have just thought there's nothing inside of there.
Yeah.
So that'd be the time on the test to go, Mr. Pavian, is there? And on the test, I'll specify like there's a cylinder in there, or it's can't mount a point. Well, that's cool. I don't know what that means. Can't mount to default mount point. Cool. Have fun with that. But typically, I would say, like on this problem, I would say you have a solid object that you bored a hole out of it. Like if you had a solid cube of wood and you bored a hole in it, that means there has to be a cylinder in here.
Okay, so a hole no matter what is a cylinder, I guess.
Yes, would probably be a good default mode. Because if I had to paint this and there wasn't a cylinder here, I'd have to paint all that inside, so I'd pretty much have to double everything again.
Think about it, if I look at it this way, it doesn't look a cylinder.
Well, there you go. All right, other questions on this homework? Yeah. Number 7. Number 7 was the hexagonal prism. So we had to find the area of the hexagon of the rectangles. Well, I think the hard part was it did give us the apothem was 12.1. You got 588?
Yes.
Okay.
And I found the area of the
Hexagon?
and then I just added those together, and then I got 757.4.
What'd you get for your 2 hexagons?
I got 169.
So we have different values here.
Okay.
Let's see where we differ. So it's half our apothum times our perimeter. So you should have half of 12.1 times 84.
I multiplied by 14%.
Okay.
Okay.
Otherwise, it sounds like you had it.
Okay.
All right. Other questions? Other questions on either homework, I guess. Volume 1 or this one. Yeah.
First homework number 9.
First homework number 9.
Yeah.
So the cylinder with a cylinder board out of it. Okay. Just so you know, if you want to get your questions already, I'm probably just going to answer a couple more, and then we have to go to today's lesson. Then we have time. I'll come back. So we have a cylinder and another cylinder, and we have an annulus. We have 2 annuluses. So I guess I did the inside of the cylinder first. So I was just looking at that cylinder that's on the inside, which is going to be our height times the circumference of the circle, right? So that's where I got the 9 times 2 pi r, which is, like I said, height times the circumference, which is 9 times that, which comes up to 36 pi. Are you okay there?
Yeah.
All right. Then I did the outside cylinder, which is just the same equation. It just now has a bigger radius, and now has a radius of 4. Because the diameter was 8, so the radius was 4. So I just put a 4 in there. I got 72 pi. Good so far?
I think I forgot to multiply by 3.
Oh, okay.
Yeah.
And then did you get the 2 annuluses?
I think I would if I did it right.
Okay. Are you okay then?
Yeah.
You think? Okay. Good. Other questions? Either volume or this homework. I don't care which one. Yeah.
Number 9 on 22. 12.2.
All right. Oh no, do I not have? Oh, there it is. Say number 9.
Yes.
All right. Number 9. Oh, that was that goofy one, right?
Yeah.
It's good. All right. So here's kind of how I'm thinking of this. What I'm picturing is, so you see I gave you the picture of the top. That is basically a half circle. But I need to subtract out 2 smaller half circles from it. All right, so can we picture that half circle? Like this is all filled in? Let me try it again. So if I calculate this area, half a circle, we can do that, right? It's just half, well, this is normally pi r squared, right? So it'd be pi times 6 squared. I want half it because it's half the circle, so I just did half of pi r squared. All right, but I don't want that entire area. I want to cut that little half circle out and cut that little half circle out. All right, so what I subtracted was, this is half a circle. Since this is 6, this must be 3. So this 1/2 circle is half of pi r squared, but I have 2 of them. In other words, you calculate 1 full circle you're taking out of there. And that's your base, and you should be able to get the height from there, right? Good? One last question. Oh, I'm not asking. Do we have one last question? Because that's about all the time I have right now. We're good otherwise? Whew. For some reason, I thought posting a video and you guys doing it would train wreck, but it worked out well. Awesome job on your ends, guys.
Thanks for all that faith you have.
Yeah.
You can do it like, how do you do it like in chemistry?
Worked really hard.
Yeah.
I wasn't here for that.
We're going to do volume of cone and volume of pyramid. All right, these are the 2 additions. So up until now, we said when I was doing the volume, I would just find the base and multiply it times the height. Well, it works for a cylinder, right? It works for a cylinder where we just say, well, if I find this area here, and I just keep doing circles and circles and circles and circles and circles and circles and circles, eventually I'll reach the top. So to get the volume of a cylinder, I just need to find the area of the base and multiply it by the height. So in this case, our radius is 5. So our volume of our cylinder is equal to our base times our height. In other words, pi r squared, which is 5 squared, times the height, which is 12, which is going to come out to 300 and pi centimeters cubed. That is nothing new. That is nothing new. I didn't put it on there and like you've never seen it before. Cone. Look at that cone. Look at that cone. Now, if we picture that cone, if I put that cone inside of this cylinder, it would look something like this. I guess. But if I was to do that, we would have the cone in here. Well, since I could fit the cone inside of a cylinder, they're going to have similar volumes. Yeah?
Is it going to be like half?
Not quite half.
A fourth?
Because it would be half if it touched all the sides, but we're not quite touching all the sides. Yeah.
Isn't it like the two sides that it's not encompassing, like new areas on the two other sides are equal?
They would be. It'd actually be equal all the way across.
Yeah.
Hey.
I'm sorry to interrupt, but I need to take Lydia.
She already left.
She just left?
Yeah.
Okay.
But Evan was on the right. Yeah.
Is it a fourth?
It isn't a fourth. It is actually a third.
Oh, darn.
Yeah.
The volume of a cone is going to be a third of the cylinder. So our volume is going to be a third of the cylinder. Well, that means it's going to be a third times the base times the height. Which we can go even further. It is a third pi r squared times our height. So in this case, we're going to have volume equals a third times pi times our r is 5 squared times our height. Here's where you got to be careful. Is 13 our height? No. Grace. 100 isn't my height. You have the right answer.
Oh,
Actually,
Oh, I thought we were referring back to the cylinder problem. I was gonna say
we
12.
are.
I was gonna say 12.
The height is not 13.
It's not 12?
Yeah, it's going to be 12. That is my height.
Thing, right?
Yeah, they're the exact same things.
Oh, I'm sorry.
Wait. Oh.
And how you could find that is this is a right angle. You could have recognized that it's 5, 12, 13, or you could have just done 13 squared equals 5 squared plus h squared. It is a right angle.
Cool.
It is a right angle. So that 12 is completely findable. You can find that 12. All right, so times 12, and that is going to equal 100 pi centimeters cubed. I just wanted to put that. This is your angle height. They might refer to this as your angle height. This is the actual height. Make sure you know which is your height and which is your angle. It isn't. It's 100.
1/3 is.
It has to be because
What is 1/3?
Divide 300 divided 2.
3.
1/3 is not 3. 1/3 is 3.
Okay, continue on. Volume of a pyramid. Volume of a pyramid. Well, a pyramid takes kind of the same idea as the cone. If I had to find the volume of a rectangular prism, we would just say either it's length times width times height, which is really base times height. So you can really think of it as 9 times 8 times the height, which is 12. And that's going to come out to 864 centimeters cubed. But once again, if we picture a pyramid, it's harder to draw on here because we kind of have to put. But we can draw that pyramid right inside of this. So it follows the exact same rules as the cone. And that's what's nice about these two. They're both a third. They're both a third. So once again, the volume of a rectangular-based prism is going to be a third of the base area. I'm sorry. Base times, what did I put exactly? Because it's like length times width. I'm trying to think what exactly I put. I guess length times width times height. I'm going to put base times height. Base area times height. I can't figure out what I want to put for 100%. I'm going to say base area times height. That might be the easiest way. Which in this case, we'd have 1/3 times our base area would be 8 times 9. Times our height, which is going to be 12. And this is going to result in 288 centimeters cubed. But I put centimeter cube. Why not get in the habit? All right, so that's the awesome thing about pyramids and cones. If you know how to find the area of a cylinder, then just take it divided by 3, because it's a third of that area. So pyramids and cones are always 1/3 when we're talking about volume. Yes?
So in like the volume of the cone problem, there's always going to be a cylinder with it, right?
There will not always be a cylinder with it. I can just give you this problem right here. I don't have to put a cylinder next to it. You have to know it's 1/3.
Okay.
Yep. You just have to find the height and the bottom circle, right? And just do it's 1/3 times the base area times the height. All right, an example. So I'm definitely not giving you a cone with this one. The volume of a trapezoid-based pyramid is 572 centimeters cubed. What is the value of B? So the first thing we're going to look at is the volume. What does volume mean in this case? So volume is going to equal 1/3 the area of the actual prism. So I'm talking about base area times the height. So I need to find this base area. I already have the height. I just need to find this base area. And we're also given the volume of it. Uh-oh. We must be looking for something else. It says, what is the value of B? Okay. Yeah, Grace.
So we have to find, like the, to solve for like, this, like the trapezoid base,
Mhm.
you have to do base 1 plus base 2, times the height divided by 2.
There you go. Yep. So our area of that trapezoid is exactly what Grace said. I'm going to put it in a little different order. I'm just going to put 1/2, but yours is fine. I'm going to do 1/2 times the height times base 1 plus base 2. In this case, we're going to have 1/2. The height of it is 6 times base 1, let's call it 8, plus base 2, which is B. If we actually solve that, it'd be 1/2 times 6, which is 3. 3 times 8 is going to be 24, and 3 times B is 3B. So this is going to be 3B plus 24. And now we're just going to fill in all the information that we know. We know the volume needs to be 572 centimeters cubed. I'm going to cut this off really quick. So our volume needs to be 572 equals 1/3. That base area is 3b plus 24. And the actual height is 22. Well, we just need to solve that. How about you give your best shot solving it? Give it your best shot solving this equation. I'll be working on it too along with you, so if you want to look up. Yeah. Yeah, okay, what'd you come up with?
18.
Yep, you got it.
Oh,